aided with MS Excel. And without further delay, let us go into the topic. The agenda was already shared to you. So today we are going to cover reserve estimation techniques. This is one among important areas in reservoir engineering. So what exactly these techniques will help us to estimate in reservoir formation? Like we are going to estimate the amount of oil in place, and we can estimate amount of oil that have been produced, not only oil, even for gas. So we have different equations that have been formulated that will help us to understand how much amount of oil was present in place. At the same time, during production, we can able to understand how much amount of oil have been produced. So there are four different techniques which were mostly applied in this oil and gas field. First one is volumetric estimation, which we are going to estimate the amount of reserves with basic parameters like porosity and area of the reservoir. So we are not going to include any kind of dry mechanisms. So if you want to know the impact of dry mechanisms and what is the impact of water encroachment, solution gas, secondary gas cap, or expansion of reservoir rock or connate water. So if you want to include all these parameters, we have to go for material balance equation. So where we are going to introduce a number of things that are happening once it starts to get produced. Generally, without any production, like just if you want to estimate the amount of reserves which were present inside reservoir, only with porosity and saturation, then we have to go for volumetric. So material balance will help us to understand the impact of dry mechanisms that have generated crude oil on both sides, like on surface and subsurface. So balance material wise, we are going to balance that. So that we're going to observe. Third thing is production decline curves. So this is a kind of iteration that we are going to do to estimate future production. So we are going to generate a model. Today we are going to discuss about production decline curves, how it will help to generate crude oil in future, like in a particular time in future, what is the amount of production oil that can be estimated, that can be understood through this technique. We have different forms are there that we are going to discuss one by one. Reservoir simulation is something which is, it has to be understood in an analytical way. So most of analogy is related to reservoir simulation. There will be data that have been generated where number of gaps and uncertainties will be present. So to fulfill that, we need different logical expressions, real-time expressions, empirical expressions. So this is the place where reservoir simulation comes into. Even softwares were there to aid all these kind of iterations. So when there is a gap, when there is missing data or uncertainty, where physically we cannot able to collect a sample from the reservoir, then we have to rely on these techniques. So reservoir simulation is integration of different logical numerical techniques that will help us to fulfill the gap in the reservoir data. So data is something which is very important. So data analytics, we are going to use MS Excel to actually compile reservoir data and how best it can help us to understand the trends of production that we are going to observe through these techniques. So first of all, we are going to start one by one. In this lecture, we are going to discuss about volumetric, material balance, and some part of production decline curve. Since the whole part is very long enough, we cannot able to, a lot of analysis has to be done based on that, but whatever we can able to do through production decline curves, that we will do. We are not going to cover reservoir simulation since each and every topic is specific and that has to be understood in a different way. So let us get into the first technique, that is volumetric estimates. So first of all, if you want to estimate the amount of crude oil that was present in place, this is the equation that will aid to help you to understand how much amount of oil in place is there. So N represents the amount of oil in barrels. So you are estimating the amount of crude oil inside reservoir through barrels. The term 7758 is conversion factor from acres to barrel. So since the area was given in acres, you can see all the specifications were given over here. A represents area of the reservoir, H represents thickness of the reservoir, width feet is the unit for that, and phi represents porosity. These are standard terms that we are going to use in reservoir engineering. Porosity units will be in fractions, so there won't be any units for that. 1 minus SWI. So SWI represents initial water saturation or connate water saturation. Both have similar properties. Like this is the residual oils, this is the residual water saturation next to oil which was present inside reservoir, which cannot be exploited. So if you ignore this part inside reservoir, remaining part will be related to oil. So 1 minus SWI represents pore volume filled by reserves except connate water saturation. That is what exactly it shows. 1 minus SW means 1 represents all together reserves will give you 100% of volume occupied. That could be oil, gas, and water. So this water which we are relating is connate water. The water which have helped reservoir rock to form into a rock. So that is the reason this water have been part of rock which cannot be exploited. So always SWI is a part of reservoir volume. So that cannot be taken out. So 1 minus SWI represents simply if it is an oil reservoir, that will be SO. If it has gas, then it will be SO plus SG. So 1 minus SW means pore volume filled by oil or gas. Then BOI represents formation volume factor of oil at initial conditions. Always I represents initial conditions, or we have another synonym for initial conditions, that is undersaturated conditions. Undersaturated represents there is no gas expansion, there is no production, there is no water encroachment. Actually, the well have been drilled, but it haven't started to produce. That means the perforations haven't opened. So there is no change inside reservoir. Like you are injecting into your body, but you haven't started to move the piston. So once you start moving the piston only, then the blood will start to flow. In the same way, the well have been injected into reservoir, but it haven't started to suck the oil. So the vacuum will be created while through SRP while sucking the oil. So that haven't started. So the condition is unsaturated. We haven't started to produce it. So there is no change of pressure inside reservoir. There won't be any pressure disturbance. So that is the significance of I. Formation volume factor is a reservoir parameter that will help us to understand the amount of oil which was present inside reservoir. So whenever we cross multiply either oil or gas with formation volume factor, means that will give you reservoir volume of that particular quantity. It could be oil or gas. Formation volume factor is a fraction that will be added to your amount of either oil or gas. So if it was not added, that will be simply taken as surface oil or surface gas. But when you have cross multiplied the parameter of oil or gas with formation volume factor, then that will give you reservoir volume quantity. It could be either oil or gas. So this is about the amount of oil that can be produced through volumetric. The formula is this: 7758 into area into thickness of the reservoir, area cross-section area of the reservoir into thickness of the reservoir into porosity into saturation of reserves, or 1 minus SWI by initial formation volume factor of oil. So this is all for oil. When it comes to gas, this is the formula to estimate gas. Same formula Only the change what we can see is here also 1 minus SWI is there. If it is a, if you are estimating, if you want to estimate the amount of gas in place inside reservoir, so you need to ignore connate water saturation. Apart from that, the reserves, what it carries is the reserves, which is having oil as well as gas. If it is gas reserve, only gas will be present. So this is about G with respect to connate water saturation. Then you can see the difference for gas. In place of BOI, it has been replaced with BGI. So formation volume factor of gas here. And then the term have been changed to 43,560 since the unit for gas, we can measure it as cubic feet from reservoir. If it is at a surface, that will be standard cubic feet. So conversion of cubic feet to here the area of reservoir was given in acres. There is a mistake, acres. When you are converting acre to cubic feet, this is the formula we are going to use, 43,560. So when area was given in acres and thickness was given in feet, then you are converting acres to cubic feet. The conversion factor will be 43,560. And then comes the amount of gas that have been produced at surface. So that is GP. That is equal to the same formula, 43,560 into area of the reservoir, into thickness, into porosity, into 1 minus SWI, that represents the reserves, total cross multiplied with 1 by BGI minus 1 by BGA. So formation volume factor at initial conditions minus formation volume factor at abandonment conditions. So initial to abandonment production have happened. So pressure have reduced. Formation volume factor also will change from initial condition to abandonment condition. So these are the two different formation volume factors that can be estimated at initial as well as at abandonment. If you have these two parameter values, then you can able to estimate the value of gas at produced condition, means amount of gas that have been produced at surface. It could be measured with respect to standard cubic feet. So this is about the estimation of oil and gas volumetrically in place. Then let us come to material balance equation. So this is second method. We are going to use Excel for this. That is simple one. So let us get into something, like when there are number of parameters that were included for estimating in place oil, then we have to consider it. So you can see this is the condition of reservoir during unsaturated. PI represents initial pressure or undersaturated pressure, where you have only two phases. One is gas and another one is oil. But after production, pressure will start to get reduced. Then you can see the reservoir have been occupied by different forms of different fluids. If imagine the gas quantity will reduce, it will increase. You can see the gas have been increased when pressure have reduced. Whenever pressure is reduced, gas will start to get increased. Then after that, evolved gas. This gas is solution gas which was present inside oil during undersaturated conditions. So once you come to saturated condition, means you came to bubble point pressure where the gas will start to evolve outside of the crude oil. So that is the amount that will be occupied during production condition. Then the amount of gas which have been injected also will occupy some amount of reservoir. Then amount of water also through injection, well, that water also will be occupied inside reservoir. So rock expansion, normally rock will be compressed at undersaturated condition. Once pressure reduces, then rock will start to get expanded. So that part will contribute some amount of oil which was present inside rock. This is compressibility of rock will also produce some amount of oil that will be occupied inside your reservoir. And remaining oil from the real oil zone, this is the oil zone which have been reduced to this. Why? Because remaining the oil which have been produced have been lost or it has been collected at surface. So the left out oil is remaining oil. And the net water, so whatever water that have been left inside the reservoir, that will be also occupied inside your reservoir. So if you see on LHS side, you can see under saturated conditions. If you see on RHS side, that will be saturated condition or below saturated conditions. So if that is the case, this is the equation. O plus G means initial oil plus initial gas is equal to remaining oil. Why? Because some amount of oil have been produced. So remaining gas, evolved solution gas, pore volume, which was contributed by expansion of water, pore volume, which was contributed by rock expansion, plus water which have been left or water encroached through aquifer, and injected water plus injected gas. So this is simple terms. I have given a form like initial oil plus initial gas, which is on LHS side. The part which have been evolved inside your reservoir is remaining oil, remaining gas, evolved solution gas, pore volume, because of pore volume expanded because of connate water, pore volume expanded because of formation, plus W represents water which have been encroached. This water is not related to injected water. Injected water is the water that have been injected through injection well. Water encroachment means because of aquifer, which is below the oil zone, the water started to get encroached into your reservoir. So that is W. And water which have been injected through injection well, gas that have been injected through gas injection well. These are the things that have been occupied inside your reservoir. When you convert these terms into material balance, you need to know what is pore volume. Pore volume can be given as NBOI into 1 plus M by 1 minus SWI. So I will be just explaining you one by one. Okay. We have to take material balance fraction as initial gas to initial oil. That is GBGI by NBOI. As I said, G represents the amount of gas which was present at undersaturated condition. When you cross multiply that with formation volume factor of gas, that is BGI, that will give you reservoir volume of gas that was present at undersaturated condition. In the same way, N represents the amount of oil that was present inside reservoir, inside the reservoir formation rock. But when you cross multiply that with BOI, it will give you the amount of oil that was present inside reservoir volume at initial condition or undersaturated condition. So O plus G will give, O plus G is nothing but initial amount of oil plus initial amount of gas is equal to pore volume into 1 minus SWI. So pore volume into 1 minus SWI will give you only the amount of reserves that were present. That is nothing but initial oil plus initial gas. So NBOI, which is this, plus from this GBGI, you can write it here. So GBGI is equal to PV into 1 minus SWI. So GBGI have been replaced by M into NBOI from this equation. So NBOI plus M into NBOI will give you PV into 1 minus SWI. So NBO have taken into common, 1 plus M will be there. So this is how the arrangement will be, pore volume into 1 minus SWI. From this equation, pore volume can be given as NBOI into 1 plus M. When you bring this LHS 1 minus SWI to a RHS denominator, then it will be 1 minus SW. This is to define the value of pore volume for material balance equation. Then actually, so this is exactly your material balance equation. So if you could see over here, NBOI, that represents oil, plus gas, N into BOI into M, that we have done already here, N into BOI into M. So this is for gas, is equal to remaining oil, initial oil minus produced oil. N represents oil, which was present, in place oil, N minus NP. N represents in place oil, NP represents produced oil. So N minus NP will give you a remaining oil. When you cross multiply that with BO, will give you a reservoir remaining oil. Plus remaining gas. The gas term, this we got it from the earlier fraction, M into NBO by NBGA into BG. Wherever the terms are there, that will be cross multiplied always with formation volume factor, either with oil or gas. So this is for remaining gas, M into NBO by BGA into BG. plus evolved solution gas. So we have three terms here, NRSI minus N minus NPRS minus NPRP. So what is RS? RS represents solution gas. It is the amount of gas that have been dissolved inside unit amount of oil. So what is that unit amount of oil? 1 barrel amount of oil will hold some amount of gas. It could be in cubic feet. So certain amount of cubic feet have been dissolved in 1 barrel of oil. That will be given it as RSI. So below bubble point pressure, RSI will exist. Above bubble point pressure, RSI will be a part of oil. Solution gas is a part of oil above bubble point pressure. After bubble point only, solution gas will start to come out. So you can witness RSI only after bubble point. So NRSI represents initial amount of oil. When you cross multiply with RSI, that will give you initial amount of solution gas present inside oil. Minus N minus NPRS, that gives you N minus NP means remaining oil. N represents initial oil, initial in place oil. NP represents produced oil. N minus NP will give you remaining oil. When it is cross multiplied with RS, that will give you solution gas present inside remaining oil. So here it is solution gas present inside initial oil minus solution gas present inside remaining oil minus solution gas present inside produced oil. This is the oil which have been lost, or else it have been collected at surface. So that have been lost. Remaining oil is the oil which was present inside reservoir rock. That is nothing but this. Remaining oil is nothing but this. So this also carries solution gas. So here we are talking about evolved solution gas, which doesn't, this remaining oil solution gas doesn't contribute to evolved oil solution. So that only we are neglecting that term. And already some amount of oil have been lost, that is NPRP. So that also we are neglecting. So what is left is nothing but evolved solution gas. Since it is gas, we have to cross multiply that with Bg at the end of your term. So this is a reservoir amount of solution gas that was present inside your reservoir. Plus CF represents compressibility of formation into NBOI into 1 plus M by 1 minus SWI into dP. This is nothing but the formula what we have written over here is in the form of CV delta P. So dV is equal to CV delta. This comes from compressibility equation. So C is equal to 1 by V into dou V by dou P. So that have been altered into CV delta P is equal to dV. So what is the dV? That is the change in volume because of the expansion of rock as well as connate water. So one is for rock, that is this equation, and connate water is this equation. Both equations are having same form, CV delta P, CV delta P. What is this V? V is nothing but pore volume that we have defined here. So pore volume is nothing but N into BOI into 1 plus M by 1 minus SWI. The same formula is here, N into BOI 1 plus M by 1 minus SWI. This is pore volume. Delta P, we should have the value of pressure so that we can find out what is delta P. Compressibility of formation, that also the data will be collected from the reservoir. So the same formula is applicable. This is for pore volume expansion with respect to reservoir rock. When pore volume expansion, if you are estimating with respect to connate water, this is the formula. CW into this initial water saturation will be cross multiplied with CW. This is the only term that has to be understood to get exact value of compressibility. That this is the term they have been cross multiplied. But if not, this is in the form of CV delta P. CV delta P. So V is pore volume, delta P is delta P. In place of C, they have written CW SWI. But here there won't. Why? Because formation doesn't, during expansion, it doesn't produce any kind of formation rock. We are not considering rock expansion contribution through solid, but only the thing connate water only will contribute to SWI. So that only will be added at this term. Plus water encroach, that is this W term, that is WE minus WPBW. What is WE? This is the amount of water which have been encroached into reservoir through aquifer. Aquifer below the oil water zone, where the water will start to enter into reservoir once the pressure gets reduced. Then comes WPBW. WP represents produced water, BW represents inside reservoir produced water. When you cross multiply WP with BW, that will give you the amount of water which have been produced. It was lost. It have been lost from the reservoir itself. Some amount of water have been produced during this process that have been collected at surface. So that water is not added in this material balance since it has been collected at surface. So we are ignoring that from water encroachment. So water have been encroached. Out of water which have been encroached, some amount of water which have been generated inside reservoir have been collected at the surface. So the remaining water will give you WE minus WPBW. This is one term. Then plus water injected into BW. So WINJ represents water which have been injected into BW will give you the amount of water which was present inside reservoir. And the same way, gas injected into BG will give you amount of gas which was present inside reservoir. So this particular saturation have been contributed through injection well. So water injection well have contributed WINJ, gas injection well have contributed to GINJ. So this is about overall material balance equation. So this is a simpler form. This is an expanded form. So if you still more normalize this equation, NBOI can be written as NBOI into LHS can be adjusted to 1 plus M. And since NBO is common on these two terms, 1 plus M, and remaining everything will be same. So N we have, NP we have. So if you adjust all the N coefficient parameters on LHS, NP coefficients on RHS, then your equation can be represented like this. NP, which is on LHS, that is into BO plus RP minus RS into BG. All these terms will balance with this equation. NP terms will be on LHS, N terms will be on RHS. So you can see every term is connected with N. So WPBW, and this is related to external sources, so they were kept as it is. So WPBW is the amount of produced water that have been lost, that have been kept over here. And WE, water encroached, WINJ. So apart from these injection and encroachment water, you can observe each term will be having N as a common coefficient on RHS, NP as a common coefficient on LHS. So why we are doing this is, see, we can able to distinguish these terms, which were the coefficients of N to be, if there is RS term is there, that means solution gas. This is because of depletion drive mechanism. This term can be related to that drive mechanism. That is depletion drive, where solution gas is the primary drive mechanism that will drive oil towards your production well. So that is about this. Whenever RS term is there, that is depletion drive mechanism. Whenever M term is there and BG is there, so this represents gas drive, free gas cap drive. So this is how we can identify that the reservoir is driven by gas cap, free gas cap. So that is about gas when there is M is there. When there is compressibility term like CWCF is there, this is because of connate water expansion or formation rock expansion. So this can be simply, we can even more reduce to this equation. In place of NP into BO plus RP minus RS into BG plus WBW can be given as F. F is equal to N. This whole term can be named it as F. F means amount of fluid withdrawal. That is equal to N into EO. This whole term, you can see this whole term have been adjusted to EO. This term have been adjusted to, since M is there, this term have been adjusted to EG. And this whole term have been adjusted to EFW. F represents expansion of formation as well as expansion of water. So F is for formation, W is for water. Since CW, CF is there, they have adjusted this to EFW. So F is equal to N into EO plus M into EG plus EFW plus water terms. So W plus WING, this is because of injection wells. Well, if injection wells are not there, then there won't be WING, BW. If gas injection well is not there, there won't be any GING, BGING. So this will become zero. If for a volumetric reservoir, that means at undersaturated conditions, there won't be WE also. So these are the conditions. If volumetric reservoir is there or undersaturated reservoir is there, that means it haven't produced, you haven't reached bubble point. That means there is no amount of free space which is available inside your reservoir. So water haven't encroached. So then W becomes zero. But currently we are not considering that. So we are keeping it as W, where we are not considering injection wells. Then the form will be in this way. F is equal to N into EO plus M into EG plus EFW plus WE. If imagine there is an undersaturated volumetric condition, what are the things from this equation can be ignored? One is WE. WE can be ignored. At the same time, for volumetric reservoir, there won't be initial gas cap. So when there is no initial gas cap, M will become zero. Why? Because what is M? M is nothing but initial gas cap by initial oil. At volumetric condition, this will not be there. G, BG, and BGI will not be there. Why? Because G will be zero. Initial gas cap will not be there. So when there is no initial gas cap, then M will become zero. That means your equation will be in the form of M is equal to N into EO plus EFW. Since this term will be zero and this term will be zero. So this is how the term have been adjusted. For volumetric reservoir, undersaturated reservoir, WE becomes zero, M becomes zero. As I said, at undersaturated condition, there is no solution gas. The gas, whatever RS is there, that will be present inside oil. So RS or RSI or RP, all will be inside oil. So all will become equal. Since all produced gas is dissolved inside oil for volumetric reservoir. So your form of F is equal to N into EO plus MEG plus EFW plus W will become F is equal to N into EO plus EFW. Since M becomes zero and W also will become zero. So from this equation, you can derive N is equal to F by EO plus EW. N is equal to F by EO plus EFW. So you can see on the y-axis, F by EO plus EW. On the x-axis, if you have the data of NP, then if you have the data for F, EO, EFW, and NP, if you draw a graph, these are the forms you can able to expect. A, B, C. So if a straight line represents A, where there is no water influx, so that means your reservoir is driven by compaction of formation or connate water. So this is because of depletion rate. Sorry, this is about there is no water influx, means your reservoir is driven by solution gas. So that represents A. When you see a curve like this, B, that represents finite boundary with water injection. So there is water drive is there, water is present over there, but boundaries have been defined over there. When you see the trend of graph, if it goes like this, there is no decrement, then it is represented as infinite boundary with water injection. So this is how it can be related. So let us see with real-time data. So if you have a data like this, estimate the type of dry mechanism with available data. You have compressibility of water, connate water, compressibility of formation, the values have been given. Initial water saturation, that is connate water, saturation is 24%. And since it is volumetric reservoir, all the values of RS have been given to be like this. And M value was given to be zero. You have produced amount of oil data is there, pressure is there, formation volume factor is there. So let me take you to Excel. Is my Excel visible?
Yes, sir.
So I have kept the data for CW here. This is nothing but 3.62 into 10 power minus 6. When you equate this, you will be getting the value like this. And CF also, we got it 4.95 into 10 power minus 6. That value also, you equate it, you got the value. The same data what I have shown you in the presentation, 24% can be written as 0.24. And RS values I haven't taken here since uh, we don't have much usage of RS at present. I will tell you the reason. Okay, we have F as well as NP and P. At the same time, this is the amount of oil which have been withdrawn. And this is formation volume factor term. And this is the one which I am supposed to estimate. So F by EO plus E, FW and NP. So let us start estimating EO. We need EO, EFW, and F value was already there. So only the thing is we need to know what is EO and EFW. So for estimating EO, what is BO? BO, the value BO is here. The value over here is there. BO minus BOI. So BOI is the initial formation volume factor of oil plus RSI minus RS. Since RSI and RS are same, this value will become 0. So 0 into BG will become 0. So there is no need to add 0 simply. So that value we will be getting it as 0.002. Then let us calculate EFW. So what is EFW? 1 plus M. In our question, M was considered to be 0. So that will be 1 plus 0. There is no need to put that into BOI. So BOI is this. Into we have two terms, CW into SWI. So CW is this, compressibility of water, into SWI, that is 0.24 plus CF, that is this, cross multiplied by 1 minus SWI. So 1 minus SWI is 0.24 into delta P. So we have to completely close the bracket. Yes, into delta P. Delta P is delta P dash 3685 minus 3680. So here I have simply given the formulas, but there are some constant terms are there that we are supposed to understand. That is 1 plus M, BOI is constant. So I'm making that parameter to freeze by adding function F4 and B1, CW. These two are constants. These three are constants, which will not change all through our iteration. So I have given that as I have freezed that value. Again, B3 also is a constant value. So I freezed that. This is not constant. So this is the value I got. Since we have 0 terms, the value what I got is this. Let me go for, no, I'm not getting the value over here. 1 plus 0 could not be the term that we are supposed to do. Okay. Yes. Only thing is I haven't kept here multiplication symbol. So from here onwards, we got the values. So this is about EFW. Here, these two parts are there so that we can. These are the parts. Actually, the thing is here we are supposed to block BOI. So we can ignore this since the titration takes the last term, which is empty. So it is showing negative. So that can be ignored. So let us try to estimate F by EO plus EW. F value was given to be this by EO plus EW. So EO is this plus EW. So all are not constant. So we can just have the value. We can ignore the last value. First and last value can be ignored. And let us try to see how the graph between F by EO plus EFW versus NP gives an impression of this graph or not. So NP is on x-axis, so left-hand side will be always considered to be x-axis, so that is NP, and right-hand side terms will always be on y-axis. So I have selected these two things, two parameters, x and y-axis. I'm introducing XY graph. So you can witness the graph is looking to be like this. So we can give the name. This is about F by EO plus. So this is the graph related to that. And from this, what is the impression if you compare with the original graph, what we can able to, this is the original graph. So what is the impression that we got from this original graph? Like y-axis is F by EO plus EW, EFW is there, and x-axis will be NP. So I will try to keep it as a direct, I will change the type of graph. Let me go like this. So this is how my graph looks like. I will go with like this. So apart from one point, so it is having a trend which is showing to look like the curve which represents C, infinite boundary with water injection. So what this particular graph, we can relate this graph with this particular graph, that is C. It is not bounding back, or else it is not a straight line. The slope is not either a straight line or it is not in a logarithmic way of moving towards the end. But here, only thing is it is moving up and slowly, constantly, it has been started to continue. Of course, few points have been away from the trend of this graph. So that can be, if you could draw a proper proportion of graph, better to select points, and we can adjust all the points. We can connect all the points like this. So you can just include a shape by connecting all the points which follow the trend. So like this. So you can see this has some similarity with your graph. So your y-axis is F by EO by EFW and x-axis will be NP. That also I will be bringing it down. Not only that, we have understood the trend of this graph, but apart from that, we can get one more information, that is, it is the intercept of this graph represents initial in place of oil. So how to define initial in place of oil from this? So here we have different values on y-axis 50,000, 1 lakh, 1,50,000. So we need to find out the intercept value. For that, we need to adjust. Let me go into a transparent scale. So like this. So here what I will do is I will just adjust the y-axis with the different scale properties. That is not labels, tick marks. Tick marks on major axis, that is cross. Axis, minor axis. If I put this marks, then I can see some more subdivisions. You can just, I will expand the graph. You can see that the interception is made near to this point. So 50,000, probably it will be 60, 70, 80, 90, and 1 lakh. So it is absolutely coming close to 70,000. So this represents your N value. So actually this represents your N value. And which is equal to 70,000 SCF, MSCF. So this is the amount of initial in place of gas that can be estimated by this graph. You can see the pattern over here also. See, this is the pattern where the intersection is there. That is the part of N. So the same way we got it over here. So this is how we can able to estimate initial amount. So you material balance objective have been defined over here. Like N have been estimated through graph. F by EO plus EFW. You have estimated the data value of NP for N. So we got the value of N over here. And what is the kind of drive mechanism that we have is infinite drive boundary drive mechanism. That means the aquifer is infinite. It does, the boundary of aquifer haven't been defined. It has a large amount of water which is pushing oil towards your production well. If B is the condition, then finite boundary water aquifer is there. So the boundary of aquifer have been defined for the condition for B. When it comes to A, there is no water influx. Only the thing is like drive mechanism is related to depletion rate, that is solution gas, which was present inside oil. But here it is showing with the trend matching with C, that represents infinite boundary. So this is how the trend of graph looks to be. This is one thing about material balance equation. So let us get back into our presentation. So next comes production decline curves. So these also very important to estimate future. It is an iteration technique. Excel will help you to get into understanding how much amount of produced oil that can be calculated in future. Like you can give any time preference, based on that you can able to identify. Okay, let me these are the type of different curves, that is harmonic, exponential, and hyperbolic. We have 9 different curves are there. So we need to identify a pattern which will match to your real-time data. Without further delay, what I will do is the equation for these graphs have been given as Qt is equal to Qi by 1 plus B dit whole power 1 by B. That means Qt represents the flow rate at any time. So time has to be defined. Qi represents initial flow rate by 1 plus B. B is an exponent. that is different for different equations. For exponential, it will be 0. For harmonic, it will be 1. And for hyperbolic, it will be in between 0 and 1. So this has to be defined. You need to have a knowledge on defining the value of B. At the same time, DI represents initial decline rate. So there is a formula to define that we are going to see that. And a time, it will be given by data. If you have all these values, this particular equation will provide you one trend graph that we are going to match with our real time. We will be seeing for different, this is how the production decline curve looks to be. So imagine the real time oil, blue color line is the one which is real time data. So you can see the real time data, and these two are production decline curves, orange one and green one. So orange one is hyperbolic predicted one. So this is how hyperbolic have been predicted. At the same time, green one is exponential predicted one. So out of these two curves, orange one comes close to your original predicted one. So based on that, we can say that your original data is having a match with your hyperbolic predicted curve. With the help of this curve, you can predict future amount of oil. So we have less time. I will try to solve one among these three curves, and I will try to match, I will try to show you how this curve will fit to your original data. So let me take quickly to Excel. I have different forms of equations for this. That is, these are the three equations, three different forms. Since exponential B is equal to 0, your ops equation, which is this, have been converted to become like this. So in the same way for logarithmic graph also, there is another form. So we have 6 different forms of equations that will generate 9 different curves. So we are not going to discuss much about these equations, but these are the equations we are going to use to derive the curve in Excel. So let me go for quickly to show you what is the curve that I'm going to derive. One is Q versus T. So I'm going to match your real-time data with this particular trend, Q versus T, and another one is log Q versus T. So I will be seeing one curve generated with Q versus T, and another one is log Q versus T, and we will match with our real-time data. So let me go quickly to Excel. So this is the data that I have. Time I have in days. It is a gas reservoir. So 30 days, 60 days, 90 days, like that I have different time scales. At the same time, I'm having amount of gas which have been produced with MSCF, that is standard cubic feet per day. And this is the data for that. So this is the amount of flow rate that we have. So right now I'm going to simply show you what is the real-time axis of this flow rate. So this is simply, I am drawing one graph. So this is how the graph looks like. So it is declining. The flow rate is been declining. This is how the match. We need to find a match for this. So let us try to solve quickly about exponential curve model, and we will try to see the match. So this is the curve, and let us try to match with that. I will try to keep it below so it will not interfere. Okay, so for exponential, this is the equation I need. So I need to define a model QT model. This is the model formula, and I need to define QT. So I have written QIE as QT. So for that, I need QI into e power minus DIT. So I have QI, that is 413. This is the initial flow rate of gas that we have, that is QI. And we need to know the value of DI, that I have to define first. Then T value have been already been given here. So first of all, let me define the value of DI. DI is here, the equation I have given. DI is equal to minus dQ by dt by QT. So dQ is the change in flow rate. So that also we have to include minus. I'm going to increase the, I will zoom it. Zoom is not. Okay. So I'm going to change, I'm going to see the difference between flow rates. Initial one minus the second one. So dq by dt. So dt is the change in time, 30 minus 60 by one more thing is the qt. So qt is not qi. So qi is 413. You can take anything away from first one, that is 413. So we can take the second one. So we got the answer of DI as 0.00174. This is the value for initial decline rate. Since you have this value, I can create model QI. So QIE from this formula, QI into exponential of minus DIT. What is QI? 430 into exponential. In Excel, we are going to use this term EXP, and we are going to put a value that minus in that bracket minus of DI into T. So DI is the one which we are supposed to freeze. Why? Because this will iterate further. So DI is a constant variable, so we are not going to move down with other values. So apart from that, remaining all are variables. So this is the first value, and this is your iterated modeled QI. So let me right now check out your exponential values with your real-time value. That is T, which is your x-axis, QMST, this is your real-time, and exponential is this. So let me see whether I have a match. So you can see this is how the trend looks to be. So there is no match. So this is blue one represents my original data, and orange one represents the modeled exponential data, which is linear value of exponential. So we have the value of exponential to be like this. Okay, quickly, I will go with the second graph, that is log Q versus T, that is here. I have, so we have seen, I have generated exponential graph, which is not giving me proper answer, so proper match. So I will go for log Q versus T. So let me build log Q for my original data. So I'm going to keep this somewhere, or else I'm going to ignore this. Okay, log Q for my original data. So that is log of, this is for my original log Q, and a modeled log Q, I need to use this equation for exponential. So for that, I need to define the value of initial decline rate for this. Why? Because the initial decline rate for linear one is not equal to the initial decline rate for logarithmic equation. So I need to define this. So we can, how to define DI in this logarithmic equation. So log QT is equal to log Q minus DIT by 2.303. Y is equal to MX plus C. So we need to convert this equation in the form of Y is equal to MX plus C. I'm going to just tell you what is Y, what is X, what is M. So Y is log QT, M is minus DI by 2.303, that is M, T is X, and C is log QC. So Y is equal to MX plus C. So that means what? M is equal to minus DI by 2.303. I have written here, M is equal to minus DI by 2.303. This equation gives me a clue. If I have a trend, XY trend of Y-axis and X-axis, my slope will be equivalent to DI by 2.303. Whether I have Y-axis and X-axis, log QT, I already log QT value was given. We can do that since we have the original data, so we can create log QT. What about T? T also we have. So the slope of these two, log Q versus T, will be equivalent to minus di by 2.303. So how to define the slope of these two columns? One is log Q and T. And the slope for this is, which one is Y? That is log Qt is Y and T is X. So T is X. I'm going to select X terms. We can define slope in two different ways. One is by constructing XY axis graph, and then we can insert a formula over the two. X term have been selected and Y term have been selected, and I introduced so this is the equation I got. So still this is not the answer. So I will add an add trend. So that will give me a supporting trend line. For this line, I will display the equation. Y is equal to mx plus c. So my slope is minus 0.0001. So I can write the slope value near the near the columns. It will be easier to get it. So I'm going to keep this nearby. And I got the value of slope as minus 0.0001. So this should be equivalent to minus di by 2.303. That means here minus 0.0001 is equal to minus di by 2.303. So then what is the value of di from this? 2.303 into 0.0001 301. So I can simply do that here. 2.303 into 0.0001. So this is my actual d value. So 0.00023. So since I have d value, I will create the model. So log Q, the model log Qt is equal to log Qi. So I'm going to ignore this graph. Okay. What is log Qi? So this is my logarithmic. So log Qi, and I have to freeze it since it is a constant parameter. Is it minus di by dit by 2.303. So I'm going to put two brackets, di, which I have to freeze, into t by 2.303. This is my first term of it, and I'm going to adjust for all. So right now I have log Q for my original data and a log Q for exponential data. Let me see whether there is a match for this. So T is common, which is on x-axis, and a log Q for my original and log Q for my exponential. So let me insert the graph. So somewhat it is having a similarity. So you can see that some like blue one is the one which is log Q and log QE. Of course, there is some gap is there, but slope is almost coming close to 12. Like that, we have to go on iterating for all 9 graphs, and finally we have to come to a conclusion that which one will have the best slope that matches with your original data. Based on that, we can define from here onwards with the model graph itself, we can predict future. We have different ways to predict future. So that can be done through this model. So this is how we can able to estimate the value of exponential. I have just given 2 graphs, but we have to continue to do it for all other graphs. So hope you have an idea of getting these graphs. through Excel. How Excel will help you to understand how it will create production decline counts and iterations. It is a powerful tool that will be helpful for number of data analytics where you can use this kind of, for production decline curves we are using this, but not only this, but we have number of other areas where you can use Excel to define number of parameters. So thank you for